Guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at question 23 from the Physics External Exam 2020 in the QCAA syllabus. If you have any questions at all during today's video, leave something in the comments and I'll try my best to answer it. If you want the link to the full exam, the link is in the description below. If you need the Physics External Exam bundle pack, the link is also in the description below. But otherwise, let's just get straight into question 23. Twin astronauts conduct an experiment when one travels with a velocity close to the speed of light to a distant planet, while the other stays on Earth. Each twin expects the other to be a different age by the time the first twin reaches and remains on the distant planet. Using the theory of special relativity, explain why the twins will no longer be the same age and draw a conclusion about which twin will be younger. So in this situation here, it kind of depends on the frame of reference. Okay, so here we can use this equation to help us. Okay, so this is your formula for time dilation. Okay, now there are tons of videos on my channel explaining this formula here. Go check them out if you're unsure. Now generally TO is the time of the person who is moving, and I'm going to say relatively, okay, because it's all relative, okay. T is the time of the person who is stationary, and again it's all relative, okay. So here when you have, let's just say, two planets like this, and there is one twin here and the other twin is in a rocket and they're traveling to this planet here, okay. If we were to be standing here and observing this, we could argue that this twin in the rocket is moving. So he would have TO and this person would have T, okay? However, it's from the perspective of the twins. That's the thing, because no one's standing on a distant planet. I haven't mentioned in this question here, okay? Now here, we could make the argument, because the rocket is moving, that this twin here, I'll say that's twin A and that's twin B. Twin A will be experiencing TO and twin B will be experiencing T. Now T is always larger than TO. So pretty much if that were the case, twin B is going to be older than twin A in this journey. However, you could also make the argument the other way because it's all relative, okay? So here, if we were to think of it like this, if I can click our object, okay, cool. So we could also make the argument as this. So if we had, let's say, this same situation here, we could also argue that the planet is moving away from this twin. So this would be TO and then this would be T. So you could make that argument as well, meaning that twin A would then be older because it would be T and this would be TO, okay? So which one is correct? Well, we've got to think of it like this, okay? So it's all about this idea of direction here, okay? Now the thing is, this twin here has to stop eventually, meaning he has to deaccelerate, okay? Which will imply he will have TO, okay? Now in this situation here, I don't think you have to say, they say draw a conclusion about which twin will be younger. Twin A is going to be younger because he'll experience TO because he is going to have to accelerate and deaccelerate from the rocket, whereas the planet doesn't. Now because of that, that will dictate this is in motion and this won't be in motion, okay? Because if two things are traveling at the same velocity, you can't tell which one's moving or not. But as soon as one starts changing speed, you can tell which one is moving relatively then, okay? Because you can make the argument, if you have two cars and they're driving side by side at 60 kilometers an hour, or you have two cars next to each other and one is still and the other is also still, they're technically the same situation. However, as soon as this one starts its engine, you know this one is not moving, okay? So this is kind of the argument you can put here. Now remember, it's only 2 marks. So you probably have to write into some very small words here. But things I would use is moving clocks run slow, reference frames, relative, that stuff is very important, okay? But anyway, If you had any questions about this question here, leave something in the comments below. If you need an external exam bundle pack, link is also in the description below, and the link for the full exam is also in the description below. I will see you in the next video.